Hi everyone. We all are always amazed with the nature's beauty. When we are in childhood days, always we had so much of question in our mind regarding why the color of the sky is blue, why clouds are white in color, or even why the sun is always red in color, right? So today we are going to study the scientific reason behind all these things. That is a special property of light rays that is called scattering of light. Scattering, the word we all are familiar. What is meant by scattering? Scattering means spreading. Scattering of light means spreading of light rays. Okay. So now we are going to define what is scattering. So scattering means when the sunlight enters into the atmosphere of Earth. We know that in the atmosphere there will be the dust particle, air molecules will be there, water droplets like water vapor will be there. So when these light rays, sunlight enter into Earth's atmosphere, it strike on the dust particle and it will scatter. What happens during the scatter is that the dust particle first it absorbs the light rays, then it re-emit without changing the wavelength. So scattering, the definition, if you see the definition of scattering, the light rays will be absorbed by the dust particle and it re-emit the light rays. That is what we call scattering. First it absorbs, after that it re-emits. So these two words are very important. Absorb the light rays and it re-emits. So this is happens with the air particle or air molecule which is having less wavelength than the size of the light wavelength. Like the light wavelength range is from 400 nanometer to 800 nanometer. So if the size of the air particle is less than that, it will absorb and re-emit, and depends upon the wavelength, the scattering also will vary. For violet color, it will be having the least wavelength, so it scatter more. And for red color, the wavelength is 800 nanometer range, so it scatter in a least way. Or if you see the intensity variation, it is the scattering rate or intensity rate depends upon the wavelength. If you see that, it is inversely proportional to the fourth power of wavelength. Intensity is always represented by the letter I. Intensity of the scattered wavelength is equal to or inversely proportional to the fourth power of wavelength. So even the intensity also will be least for the violet rays because the scattering will be more. If more lights are scattering means the intensity will be very less. And for red color, it will be having the least scattering amount. Okay. Now, on the basis of this scattering, now you understood that scattering is the reason for the blue color of the sky, white color of the clouds, red color of the sun. But particularly, there will be some little variation. When we come to the explanation range, along with the scattering, we will see how it happens. Same process happening for all the case, but we are getting the different colors. We will see how the sunlight or during the evening and during sunrise and sunset time, why sun seen like reddish in color. So that's the first application of scattering. Sun. During, we know that we already told that red color is having higher wavelength, so least scattering is happening. So during the morning time and evening time, if this is the earth, during the morning time or evening time, if this is the position of the sun rays has to reach this much distance. Comparing with the noon time, only this much distance will be there. If we compare, I'm just marking it as A and B. If we compare the distance of A and B, you can easily understand that during the noon time, the light has to travel less distance to reach the earth. But during the morning time and even the evening time, light has to travel long distance. So during this traveling time, the blue end colors like violet, blue, indigo, that end colors having less wavelength, it will scatter before reaching the earth's surface. So when we watch the sun during the morning session or evening time, only the red color will be balanced. If you see like this way, white color is traveling from the sun, minus blue will be scattered. So the balance color what we get in the form of reddish, not exactly red, but the one end is red, orange like this will come. No? So the reddish color will be the balance. So that is the reason the morning during the sunrise time and sunset time, the balance color which is available from the sunlight is red. The rest of the colors will be spread or scattered in all directions. That is the reason we are seeing the sun as reddish combination during the morning section and evening section. Now, what is the reason we are seeing the sky as blue in color during the sunny days? So, the same thing is happening during this time. During the sun, especially during the sunny days, we used to enjoy the color of sky as blue, perfect blue. So, we know that blue color, the blue end is having the wavelength less. So, the entire blue section will be scattered off. So, when we watch the sky, other than the direction of sun, when we see the sun, obviously it will feel like reddish in color or orangish color. If you see the opposite side or other sides of sun where it is placed, we see like blue in color. So that area, the entire violet color or blue color will be scattered more. So that light will reaches our eye and we feel like the sky is blue in color. And if we see the sky during the noon time, just above, when the sun is just above our head, when we see the sky, most of the time we feel like white light or white in color. So that means by that time the sun will be here. So the rays has to travel less distance to reach the earth. So the blue color, almost all the color faces same amount of scattering, or only less distance has to travel, so less amount of scattering will happen. So all together we feel like white in color during the noon time. So these are the three reasons for these things. And one more thing, sometimes we feel that why clouds are white in color. So this is another reason for that. Clouds are white in color. The reason is that I already told you that if the size of the air particle or water vapor is more than the wavelength of the light, entire light from red end to violet end, the scattering rate will be equal or the same extent scattering will happen. So if you see the water droplet or water vapor, which is, we know that the clouds is filled up of water droplet, right? So when the light rays incident on the water droplet or the clouds, the size of the water droplet will be, or the size will be more than the wavelength of the light. So all the colors red and to violet and entire light will be having the same extent of scattering. So all together same extent of scattering means same way we feel like white in color. That's the reason we feel the white clouds or clouds are white in color. And if we see the moon, we always feel the sky of the moon as dark in color. The reason is that there is no atmosphere for the light rays to scatter. So always we feel like the sky of the moon is dark in color. And if you are going as an astronaut or if you are going in a spaceship, we feel the sky is like dark in color. But when we are away from the earth and when we watch the earth from the space, we see like a blue color. Earth is like blue in color. The reason is that when we are outside, we know that the earth is covered with atmosphere. So there the light rays have the scattering and entire blue color will be scattered everywhere. So that is the reason we feel or we used to see or we used to feel the earth is like blue in color when we watch or when you used to get the picture from the space. The earth is always blue in color. And we know that for signals, for dangerous signals we were always using the red color, or especially when we are going to the hilly areas or hill stations, we'll be having fog light, and fog light always will have like yellowish color. The light is always in yellowish color. The reason is that it's also coming under the category of high wavelength light. So as it is having less scattering, it can penetrate even through the dust particle and the fog. So that is the reason for providing dangerous signal, or even for the headlight, for fog light, we are using that N colors like yellow color or red color. Even for the gadgets like TV remote and all, to get the infrared radiation, that's also red in color. So there also we are using the application of scattering, which is having the least scattering light we are choosing to utilizing for this application. So these are some of the reason or some of the application of scattering, and it boosts the beauty of nature. Thank you.